Okay, pay attention. So if you look here, it says use, you're sort of starting to see that. Use this key to fully define this vector. This is on page 9 of 14. And the key says key, AE key. Obviously something got messed up, right? That doesn't make any sense. So I put on, in topic 1, like corrections on the packets. There's a couple on 7 of 14 in the answers. And then 9 of 14, key is screwy, see? Use 1 centimeters equals 1 centimeters, and standard 360 degrees for an angle. Okay, so 1 centimeter equals 1 centimeter, and 360 degrees. Now this line came up when I just did the picture of it, but take your ruler and someone tell me what they measure the length of that to be. .45, number 5, page 9 of 14. The key should read 1 centimeter equals 1 centimeter, but it doesn't, but I put it in the corrections. And this is 0 degrees to 360 degrees, right around. So that, when I say that, just going around that, so this is 0 degrees here, okay? Then we have like this one, that would be like 45 degrees, okay? Going straight up and down would be 90 degrees here. In the middle over here would be 135 degrees. That's 180 degrees. Going down like that is 225 degrees, right? This is 270 degrees, and this is 315 degrees, and then all the angles in between too, right? Now, Michael, what did you get for the length? Oh, 3.8 centimeters. Okay, so does that sound right to you guys? Why not? Try it again. Measure it again. Are you measuring it from here to the tip? It's the whole vector, 3.6. Okay, is it about 3.65? Because we can estimate, the proper way would be to actually estimate that last one. So you would write it as like 3.65 centimeters. Now since it's a 1 centimeter equals 1 centimeters, that's all we have to do. Now how are we going to get the angle? Well, we're going to bust out our protractor, right? It's a little bit big. That I can nicely shrink down. Too small. And then when I put it on the crosshairs on this tip, the tail of the vector, when I put the crosshairs right on top of that, and then look at, I could see that it's reading off 142 degrees. You see what I did? Make sure you can do that with your protractor, okay, so that you know how to do that. This is all graphically. We haven't really done anything mathematically with this, have we? So at 142 degrees. Does that make sense? You're on the wrong page. 9 of 14. We're working on this one. Oh, you already did it. Okay, you're going to change this to I changed the 0 to 360. You did it, probably didn't look at the corrections, so try to put it in yourself. Yeah. All right. So on Schoology are corrections in the packet. Okay. Now, next problem. This is on the next page. Okay. Oops. On the next page, we have this one. Given vector A and vector C, draw vector B such that vector A plus vector B equals vector C. Now, when you add vectors, right, how do you add them? How do you arrange them? The tail, so you take tail, head to tail, right? The head of the one, the first one to the tail of the next one, okay? So, let me just draw these vectors in. We'll draw a green one for A. We'll draw a blue one for C. And then I'll draw another. I'll put it on. Let me grab A. Whoops. Here's A. So there's my A. It says draw vector B so that you get C. Now C is the what of A plus B? C is the resultant. That should be blue. That means it's the sum of A plus B. It's vectors. Okay? So when we draw the sum of two vectors, if we had two vectors and we arranged them head to tail, right? And we wanted to draw the sum, where should the sum start and where should it finish? Sam? It should start at the tail of A and finish at the head of B. So we have that sum, so I know it's got to start at A, and I know it's got to finish at B. So now I can draw in B, right? By just taking C and putting it over on A, the tip of it on A, I can draw C. I mean, I have C there. Now I can draw B. And B would look like, head, tail would look like that. So now I drew my B to match up with that. All right. We did yellow. We could do black. All right, good enough. Let's find the sum of A plus B plus C plus D plus E. Okay, so we need someone to start us out. So to take A and put it somewhere. And Wendy, you want to do that? So you just grab A and put it somewhere. Actually, hold on. Wait a minute. Okay. Oh, you're on top of it. You learned fast. Took me 4 weeks, and just grab it and pull it. Wherever. No, pull it down. We're going to do a new one. So down below the A plus open space. Keep going. No, just the A. All right. Good. Okay, that's it. That's all I want you to do. Hana. Put B on. She's got her B, and they are arranged. How they arranged? Get it nice and close, right on the head of the one to the tip of the other, right on the tip of the head, the tail, the head to the tail to the head. Perfect. C, Lorena. She's grabbed C. Don't be afraid to press the board. Okay, good. Now we got C on there. The sum of A plus B plus C would go from here to here. Okay? Now D, Gracie. We can move down. You still grab it up there. And then E, here comes Kelly. Okay, now here's the big one. Annika is going to draw the resultant. Let's make the resultant pink, okay? Or is that pink? It's kind of pink. Start, or draw it, yeah. How would you draw the... No. Just do it with your finger. Sorry, I mean, I didn't need to freak out. There's our resultant, right? Good. So that's our R, our resultant. Good. Now, what do you think would happen if we flip these around? I mean, like, okay, so let's see. If we do that, E plus D plus C plus B plus A, what happens? Start it off. Grab E. You have to go up, up. Well, I think we could. Here, I'll help you. Grab E. Start it off. And place it. Now, come on up. Grab D. Grab D. Bring it down. Hold on a second. Let go. Next one, come up. Now it's C. Bring it down. Let go. Okay, good. Now, B. B. And now, E. Why aren't you up here? You're going to be next. Drag it. Oh, I'm sorry, A. Did we do B? Did you do B? No, you're right. Now we need A. I went back to the beginning, sorry. All right, now, you grab R and see if it matches up. Hold on. Grab R and place it where you think it should go. There it is. Yeah, there you go. It is the same thing, isn't it? Right? So it doesn't matter the order. Now the other thing, just to see, is they would all be the same. Yeah, yeah. So the other thing we could do is like, if you had A, B, and C here, A, B, and C, right? If I did if I just summed A, B, and C with a vector, I'm running out of colors. If I did those, that would be A plus B plus C, okay? What does A plus B plus C plus D plus E give you? It gives you R again, right? So you could sum them up and then add more on, okay? Now there's another thing in here called the equilibrium of the resultant. And it's the same thing as a resultant except in the other direction. So if I was to, whoops, grab our resultant here, right? So the equilibrium is the same thing as the resultant, but in the opposite direction. So that the resultant plus E, which is the equilibrium, equals 0. So the way I can get it on here is I can flip it in the left-right, and then I can flip it in the up-down, and now I have, whoops, we'll make this one a different color. That's our equilibrium. You can see if you, yeah, this is E, the equilibrium. This is R, and E plus R equals 0. See, because if you arrange them head to tail, where do you go? You get 0, don't you? So if and you can also get the equilibrium by it's a 180 degree difference from the other one with the same it has the same magnitude but 180 degree difference. So this R here, if I use the protractor, boy, oops, way down there. If I measure R, R is at, well, this is 360. So R would be around 3, well, a little less than 330. It's coming out at like 328, we'll say, okay? So what's 180 minus 328? Or 328 minus 180? You just throw stuff out? Let's see. 148. All right. Okay? You see the equilibrium is the same magnitude, but at 180 degree difference. Okay? All right. Trigonometry and vector components. Did you find trigonometry confusing? But of course you're doing it in math too, right? So if we have a right triangle, first off, let's say like this, a right triangle, and we need a symbol for our angles. So the symbol that we commonly use is theta. Theta. This thing right here is called theta. It's a Greek letter, right? That's all, right? A Greek symbol like alpha, beta, omega, theta, 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 gamma, beta, something like that. Okay. Now, we have three different sides to our triangle. Ding, dong, doom, right? This side that is right here, what do we call that side across from the 90-degree angle? The hypotenuse. Right, Kayla? What do we call the side across from theta? The opposite, right, Lorena? What do we call the side next to theta? Mikhail? The adjacent? Then we have some relationships. These relationships are also stored in your calculator, right? So what we could say is that for any specific angle, we would know the ratios of the sides because we know it's a right triangle. Okay? So if it's for a right triangle, we would know the ratios of the sides for any specific angle. So we could say something, the relationship is this. We call it sine theta, okay? But we abbreviate it. That equals the opposite side over the hypotenuse side. But it's abbreviated sin theta equals OH, okay? So we abbreviate that. So here's the long form. Well, that's not fitting in. Whatever. Okay, that's a short form. And then the other one's called cosine theta adjacent over hypotenuse, right? Yeah. What it means is, it means the ratio of the opposite over hypotenuse. So you would say to your calculator, you would say, what is the sine of 30 degrees? And what it will give you, when you say that, it gives you the ratio of the opposite over the hypotenuse. Okay? So it's not multiplied. No, it's like one thing. Cosine theta is A over H, abbreviated. Okay? And then the last one for us is tangent of theta, which is the opposite over the adjacent, and that is tan theta equals O over A. So we have three things, okay? We got sine, cosine, oh, crust. That's all right. Tangent. A good way to remember this, anyone know? Mikhail? SOHCAHTOA, right? So sine is opposite over, oops. No, that was right. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So SOHCAHTOA. So Monica's feet are sore from playing so much hockey. What does she do when she has sore feet? She sokas her toa, right? Or you can remember the great Native American chief, SOHCAHTOA. Now, my geometry teacher, she made us follow her around the room chanting, SOHCAHTOA, Soka, and we just chant. Okay, no, we're not going to do that, but I don't want to steal her thunder. All right. So does that make sense to people? Okay. Some of you have had it before, so it makes sense to you. But what this allows us to do with vectors is, first off, we can remember those component things we found in the x and y direction? We can do that. We can sum vectors with this and other things, okay? So let's see. Let's go to the first page of the packet just to get a little practice with sine, cosine, and tangent. Oh, we can find the angle. We can find the components. We're going to do all that. First off, I didn't label these right triangles that they are, okay? Right triangles. So let's look at some, oops. Let's look at this, okay? What do we have to do with these right triangles? Wendy? Okay, so how do we do that? Right. We Pythag it, right? Okay. Now, this would be the same as, okay, let me just do it. So A, let's say it's 60, plus B, which is 10, equals C squared, right? So 60 squared plus 10 squared is 3,700 meters squared equals C squared. What's the opposite of squared? square root, right? The square root, 3,700, is 60.83 meters. The square root of meters squared is just meters. Now, you don't have to do this on your packet, but let me just show you something. Let's say this was vector A. And then this was vector B. What is the sum of A plus B when they're arranged nicely with head to tail? Well, it's not 70 when they're arranged like that. It's the vector sum I'm asking for. The vector sum, you start at the tip of the one and go to the head of the other, don't you? Right? So how would I find this resultant, R? I would do this, right? So R is 60.83 meters from our Pythagorean theorem, okay? So when you're summing vectors mathematically like that, before we used a scale, we used a ruler and a scale, right? Now we did the sum, but we can use mathematics to come up with it, right? How am I going to find this one? David? Jack? 50 meters squared plus b squared equals 80 meters. So the same equation that we have here, except now we're solving for b, right? So 80 squared minus 50 squared, because if I bring that over to the other side, right, it's 3,900. So now I have b squared equals 3,900 meters squared. Everybody see how I got that? You find this, you find that, you subtract that over to the other side. Square root it. $62.45 is B. Okay. And again, in this case, A plus B would still give you C or R. Okay? Yes, yes. You have your calculators for your test. Now, when I was in school, okay, we only had, you were shown how to look up sine and cosine ratios in books. Okay? We had calculators. They still showed you that at that point, how to do that. And so they would have big books of the ratio. So if you wanted the sine, what is the ratio? So if you looked up for an angle, say 33.568, you could look up what the ratio of the opposite over the hypotenuse is and get the sine of that angle. So, and then on this one, it's the same sort of way, right? So you would just solve for that, okay? So that's a little practice on those. Let's look at these. This is a good thing to see if you're... So what, in this case, we're asking our calculator for this part. is use your calculator to find these things, okay? And we're saying, what is the sine of 0, the sine of 30, 60, 90? What is the cosine 30, 60, 90? So that's asking, what is the sine when the opposite over hypotenuse ratio is 0? No, no, that doesn't make sense. What is the opposite over hypotenuse ratio for an angle of 0? Well, what would be the opposite side? 0. So what would be our answer? 0. So let's try our calculators. Press sine 0. Tell me if you get 0. So everybody should have their calculator out to do this so that I can find mistakes you might have. Now you juniors and your seniors, okay, sometimes you guys are working in radians. So if I put you in degrees, because we only work in degrees, you got to remember if in math you're in radians, you got to go back, right? So this should be 0 degree, or 0, sorry, gosh. Now let's try the sine of 30. So here we're saying, what is the opposite over hypotenuse ratio for an angle of 30? Okay? What did you get? 0.5. If you plot in sine 30 and don't get 0.5, your mode must be in radians. So change your mode to degrees. Are you good? Let's see. So we'll go, I don't know. It's got to be on here. Let's try OPTN. Oh, that didn't work. All right, so see where it says angle radian? I hit menu. No, I hit setup. Oops. Oops. I'm going to hit setup. So shift setup. I'm going to go down to this thing that says radian. How do you change that? No, darn it. I got to change it to degrees. How do I do that? Hit F1? Yes. Okay. So now it's in degrees. So now when you do sine of 30, it's 0.5. Okay? Anyone else need help? Oh, don't do second. Just do sine of 30. Okay? Anyone else not having their calculators work? Alrighty. Your homework is just to work on this packet. Okay? I know. Yeah.